Good morning. I'm Margie O'Driscoll, and on behalf of the Center for the Innovations Board of Directors, I'd like to welcome you to today's webinar. The mission of the center is to reshape the architecture, engineering, and construction industry for a better tomorrow. So thank you for joining us on this journey. We'd like to take a moment to express our gratitude to the many sponsors who make our work possible. Thank you. The Center for Innovation recently concluded our fall forum, which included talks with people charged with rebuilding their Ukraine, the Bosch innovation story, and a deep dive with several building owners about their view of innovation in 2050. If you missed any of these webinars, please check out all our past webinars on our YouTube channel. Today, we will be discussing the design to value approach with two leaders from Bryden Wood. Now operating from 8 offices worldwide, Bryden Wood is widely known as a global disruptor for pioneering new approaches in the design and construction sector. They seek to transform how value is generated, enhanced, and retained in the built realm. They use the combined powers of data, construction technology, and imagination to establish the most effective solutions for complex buildings. Bryden Wood has led major design and construction projects in pharmaceutical and process facilities, data centers, aviation, healthcare, education, residential, water infrastructure, and transportation infrastructure. The firm has just ventured from across the pond and is opening an office here in the United States. We think we have a lot to learn here about their approach, so we're delighted to have two leaders from Bryden Wood joining us today. Jaimie Johnston and Maria Mamura will discuss the manifestation of design to value as industrialized construction, giving examples of recent projects and discussing the potential for wider adoption. They will draw on the platforms approach and examples of creative technology solutions that are being applied globally in transport infrastructure and the data center sector. They will illustrate how warp speed progress in rapid engineering modeling, digital configurators, and reference design is irreversibly changing architecture, engineering, and construction, and offer some ways in which companies can avoid being left behind. Here's a little bit of background about both of our speakers. Jaimie leads the application of systems to the delivery and operation of high-performing assets for Bryden Wood. He's an authority on the platform's approach to design for manufacture and assembly and works on new data-led digital workflows for government and private sector clients around the world. He's the author of benchmark strategic documents on platforms that are now the foundation of the UK government's drive to create more productive, value-driven opportunities within the construction sector. In 2021, he was awarded an MBE for services to construction. Jaimie is joined by Maria Mamura, the Director of Creative Technologies at Bryden Wood, where she specializes in algorithmic design work. She leads a team of computational designers, architects, and engineers to create disruptive new digital approaches to automated design. Maria is a registered architect and specialist in computational design. Welcome to both of you. Jaimie, I think you're going to get us started.
Yes, that's right. I'm going to kick off and then I'm going to hand over to Maria. So for those who joined last week, this is part 2 of a couple of webinars we've been doing. So for those who joined last week, welcome back. For those who weren't on the webinar last week, I'm going to give a very quick canter through before I introduce Maria. So the sort of theme of these two talks has been an approach that Bryden Wood's been developing over 25, 27 years now, which is sort of relentlessly pursuing best value for clients in whatever form that takes and whatever tools and techniques we need to develop. So broadly speaking, this is a sort of project life cycle for us. So we tend to start now not with a brief, but with a problem statement. So a client wants to achieve a particular outcome, be that a business outcome, be that sort of something for government, whether it's an educational healthcare outcome. So we tend to work now an awful lot at the front end of projects with clients, really understanding their problem, understanding the context in which they work, and then setting the kind of course for the rest of the project. Very often that results in assets. One of the things we talked about last week is quite often the answer is not an asset. We find ways to leverage capacity from existing assets. For instance, if the answer is an asset, then we work through this sort of process of fast iteration, We talked last week about how we use chips as a way of aggregating intelligence across the business, and in the early days we were sort of manually using chips to fast iterate, but Maria is going to show you how we've now moved that into a much different space, a much quicker space. Once we've sort of gone through that process, what we found is that the rigor in understanding adjacencies, dependencies, things that drive a particular asset, we can often codify and automate, which Maria is going to talk around. The output of that then is often that we have a sort of digital kit of parts, which turns into a physical kit of parts, and that's the sort of industrialized construction piece. So last week we talked about this kind of front end process. This week we're going to talk about these two bits, particularly automated design and industrialized construction. So this was the sort of broad project life cycle we've talked about. Data analytics, chip thinking we talked about. Reference design is where, for a lot of our serial clients now, what they want is a kind of centralized, optimized design for a particular asset, be that data center, hospital, and then a way of adapting it and localizing it for specific sites and particular geographies. So that's a process that we've been doing for quite a long time now. Maria and her team have been working out how to really refine that process and start to dramatically increase the speed with which we can do that, and even open up even wider the kind of potential area of or solution space that we're looking at. So one of the things that hopefully came across last week is the process of chip thinking, particularly in the way that we aggregate business intelligence, the way that we aggregate knowledge from stakeholders and put it together, is increasingly giving us a data set to work with. And lots of clients now have reams of data, but I'm sure you all know this, the sort of gap between data versus information versus insight. There's a few steps there that often people find difficult to hurdle. And so we've been increasingly working out how to leverage clients' data and do things with it to speed up the design process. So probably a few years ago, everyone's seen a version of this slide where it has BIM in the middle and as the sort of central source of truth, with all of the different stakeholders looking at it. Increasingly now we see data as being the kind of central repository of stuff that we use. The BIM model is one view of it, but Maria and her team have been working out how to leverage that data and develop not just the same sort of workflows, but faster, but different workflows that test more ideas. So in our sort of design to value space, you know, one thing you could do is just automate a traditional design workflow and be much quicker. And for sure, that might be helpful. Anyone who was tuned in last week will know that through the sort of design to value thing, we're not just looking to do things quicker, we're looking to do things better. So we'll actually use the speed that we get through these automated workflows to actually test more ideas, consider more things, do more simulations. So we're now using that speed not just to be faster, but also to find better solutions, more highly targeted solutions. So I'm going to hand over to Maria now, who's going to talk through what that really means for the creative tech team, how that team's evolved, and some of the kind of best practice that we've been starting to evolve and develop. So if I stop sharing now and hand over to you, Maria.
Thank you, Jaimie. So before I talk about the ways that we apply automation, I would like to introduce our team. And so in Creative Technologies team, our focus is on how we can apply automation in the industry, how we are interested in technologies, and we want to explore the capabilities that the technologies can offer. We use the power of data, and we deliver software to our clients, but we are not software developers. So who we are a group of architects and engineers, and we are all specialized in different technologies. We are curious people that we use our creativity on shaping the data, and we explore how the technology can make a meaningful impact in our industry. So we developed, like we structured throughout the years, we structured our team in a very careful way. And actually, as we increased as a team, we all had the voice and we shaped our team and our qualities together. And this is why, so we started back in 2017, And in 5 years that we exist as a team, only by year 4, we managed to hire a software engineer. And this is because before we hired a person with a completely different background to us, we want to make sure that we explore in a very critical way the technologies that we want to use in our processes, the technologies that would help on delivering the products we want delivering to our clients. So this is how it took us today that we have 5 software developers integrated in our team. And it will be worth mentioning that across all projects and across the whole team, we create clusters of people with different backgrounds. So the software developers don't work on their own. We create different groups depending on the needs of the projects, or we create different groups depending on our interest to different technologies. So we make sure that we keep a diverse shape across the team, because we believe that when we have many different voices coming from different cultures, not only technical backgrounds, this is the way to raise constructive discussions and create debates, because we always need to question ourselves, which are the technologies that we need to use and what is the best way to use the technologies in order to deliver the right product for our clients. So as a team, we have worked across many different projects, and these are digital projects, these are digital workflows or web applications. It could be different configurators. And actually some of those may focus on how to use the geospatial information mainly. In other cases, we develop platforms that allows us to explore different configurations of different buildings, such as data centers or homes or schools. But also we focus on projects that allows us to explore how we can automate the construction and apply design for manufacturing. Across all the different projects we work as a team, we can say that we apply one common methodology in principle. So the most challenging part of this methodology is how we can understand the needs of our clients and how we can get the right context, translate the machine readable format. So it is very important that on any stage and on any project and on any stage that we work, actually, we have the constant communication with our clients, and we build this collaboration that we create a common vocabulary between the client and our team. And also we translate in the right way the information that we have, so we can take it through the technologies that we use. And then it is very important for us to make sure that whatever we do in our processes and however we translate this information into a data set, we bring it back to a human readable format, and we bring back the evidence of what we analyzed and what we developed as a team. So again, it is very important to have our clients engaged across the whole process of our work. And we want a constant feedback from them, because whatever we do in between, which is the creative part for ourselves, where we test our methodologies, where we connect all the different technologies that we want, and we explore all the information we have. If we don't bring it back in the right format, then we'll just remain as a black box for ourselves. So I would like to share with you a couple of projects that we developed as a team by taking you through the journey of our team throughout the years. So as a team, we've grown in confidence over the years. And actually this started also when I joined Brighton Wood, when we weren't really aware of the capabilities we had back then and the impact that we would have in the industry. But by having the right clients on the right side and grabbing the opportunities we had back then, we were quite ambitious, and we really pushed our boundaries as a team, and we tried to use things that we never used before in order to create a much more structured team and much more confident team. But we still have this curiosity that we always ask ourselves, okay, how we can change the things that we have already made and what comes next for this industry. So in the first phase of what we call innocence, it is the phase that in terms of technologies, we use whatever we had available back then. We used software that were familiar to architects and engineers. We used available add-ons to help us deliver what we want to deliver, and we were sharing data through file sharing. And I would like to explain this process like through the very first projects that we got as a team, and that was the rapid engineering model by National Highways. I would say it's worth mentioning here that the first requirement that we had from National Highways was to create a BIM library with standardized components that they would use in construction. And that was a relatively easy task for us, but because in Brighton, we always cared about how to standardize things and how to standardize not only the process, but also the assets. But on the other hand, we quickly identified that if we focus only on this part, we wouldn't change radically how the industry works, because on the other hand, like National Highways, they also had the vision to innovate the way that they work and change the workflows that they use. So we weren't that innocent back then, though, to suggest like a very big scope. And we tried to identify small case studies from the very beginning of the design process, just to prove back to our client that if we change a few things from the beginning of the design process, then it could have like a huge impact at the later stage of the construction. And through this collaboration, and also by proving like what we had in mind and the impact that it will have like in the way that they work at the moment, we create this confidence between ourselves. So we managed to get a much bigger scope where we were asked to create a workflow, an automated workflow that actually would place all the assets required across the whole network of the country. And this is what you see on your screen. But actually, our focus was how we can translate the design guides we collect and the experience that we got from the engineers that were involved in the design of highways, and how we can convert this information into a data set. So we had to deal with lots of information, and we were trying to depict that in different graphs in order to give back to the engineers and the users of this workflow, like the conditions of the road and that they had to deliver a specific design, and in order to enhance their decision process. It would be worth mentioning like here an example about visibility conditions. So first of all, like as a team, we aren't responsible of designing highways, and definitely the experience that those people have is incredible and super valuable. But what we did is that we want to provide to them a tool that they could have available on all the information that they need across the design stages. So for example, we could provide across the whole network and across the whole and across any location on the roads through running like many algorithmic processes, the visibility conditions of many different assets. So that was a huge set of information that our engineers, that they had to use the workflow, realized that holding this information much more in advance in the design process, it could help them make much better decisions. So then as we had more and more experience as a team, we worked towards the phase of ambition, where it was like the more playful phase. And in this case, we didn't rely on just on the software that we had available, but we created platforms. We used available platforms, and we started customized processes in order to deliver platforms and tools and applications for different users. An example of that is the Prism App project, which was a project that was delivered to the Mayor of London. So what we wanted to do with this project was to create a platform that any architect or any user or developer could access it. It is an open source platform through which we can explore feasibility studies across the City of London, where we capture all the local design guides and it is connected to a list of components based on specific methodology for design for manufacturing, which means that we can explore what we can build on specific sites. We can explore the data and the information we have for the area by accessing, by having information about the green spaces or the traffic or different bus stations. But it is more important to see like directly to get the live report of the performance of the buildings, of the list of components that we would need to use to build, to create these buildings, and any information that we need to evaluate whether what we design is what we want to achieve or how we can make like our design better. It's worth mentioning also that the rapid engineering model is an ongoing project, and through this phase, actually, it was a project that we also challenged again the way that we initially structured the project. And by getting more knowledge, for example, for the PRISM map, we also transferred this knowledge to the other projects that we worked on. So it is very important for ourselves to constantly challenge the work that we did in the past. We don't want to reinvent the wheel, and definitely we want to reuse the innovation that we have applied in previous projects. And that takes us to where we are today, in what we could call like the phase of confidence, where we create much more complex systems. We create connections between software and tools to develop that allows us to, first of all, apply much more complex algorithmic processes, analyze, run millions of iterations of design options, and we can use multiple services, database, and servers. So through that way, what we can give today is that we can give control to our clients, and we can expose the design solution space that we create. And in order to make that, and it's very important that by building the communication with our clients, we can provide the tool that they are able now to explore their design solutions and improve the design on their own. So it's worth mentioning that what we don't want to create as a team is to give like a black box again. We want to expose the process. We want to expose the risks and the challenges for any design option. We want to make our clients part of the design process. And automation wouldn't give like one final solution, but actually it will give us the direction to improve the products that we want to deliver. I will hand over back to you, Jaimie.
Brilliant, thanks for that. Yeah, so just to build on that final point Maria made, again, that for us is always the sort of, or an interesting thing that we're trying to do through design to value. So the idea that we've actually automated ourselves out of a job. For some of our clients, they actually run their own configurator, they do their own test fit designs. That's enormously powerful for a client who would normally have to procure a design team for every project. So my favorite use case, one of our clients was saying that actually, because they can use some of these tools, they'll do their own test fits, we would call it. So kind of feasibility studies on a site. They can do that incredibly quickly, and they're becoming a preferred purchaser of sites because vendors know that they'll get their design and due diligence and permitting done in a fraction of the time than a normal purchaser would. So they're actually preferred, well, they get into market much quicker because they can buy the sites because they can do a lot of testing very, very quickly up front. So that is an enormous transformation in their internal capability. And again, designing our way out of a job feels a bit counterintuitive. But again, if you think through of, relentlessly adding value, that's where it takes you. I think Maria didn't mention, but just to give you a sense of the potential time savings, so rapid engineering model, that this ability to for Maria's team to provide clients with a configurator they can use themselves, so it changes their internal capability. Again, that seems quite counterintuitive to design our way out of a job. But again, if you're chasing value for clients, that's where it takes you. I was also going to say that the rapid engineering model, to give you a sense of the kind of impact these things have, it now does an evidentially better design in 2 days than a human team does in 6 months. So because of things like it checks every visibility condition of every component, it finds better solutions than a human team does, and it does it much, much quicker. So that's the sort of change of pace. And again, because we've given that code to Highways England or National Highways, again, it's helping them to become a more intelligent client, a more capable client. And again, that's a massively powerful thing for us. So I'm now going to talk about the sort of last sort of topic, which is how that then translates into industrialized construction. So I showed this slide last week. This is sort of going full circle, really. This is where we started as a practice, was trying to work out how we could replicate some of the benefits of manufacturing, what that would look like in construction. So we've developed lots and lots of different construction systems, more like manufacturing sort of systems for a whole range of clients in all the sectors that Margie talked about right at the top of this introduction. So you can see here a whole range of solutions, from large volumetric, panelized, componentized solutions. So we use a range of techniques and a range of materials, and again we sort of draw down on this sort of palette as we work out what clients need. So this is an alternative view of that. So over a number of years now, you can see there's a whole range of solutions we've developed. One thing that we didn't used to use this terminology, but you can see on this slide, is that we increasingly use kits of parts or components that can be configured in lots of different ways. So certainly in the UK, there's a real interest in volumetric modular construction, which is making a building size bit of building in a shed and then bring it to site, which is certainly part of the spectrum of solutions. What we were finding, though, was that there's a real tension between what clients need, which is very site specific, very brief specific assets, and what manufacturing likes, which is identical components rolled out at scale. So we've always been trying to crack that or resolve that tension between how do I use standardization at a certain level but still get complete architectural freedom and flexibility at a kind of building level. And that's led us down into using much more granular components that we repeat and can be configured in loads of different ways. So if you think about Lego, there's a number of components, they're completely standard. That does nothing to stop you doing something completely bespoke every time. So that's what we've been trying to crack over years, is how to sort of make sure that we don't relinquish the quality of the building. If at any point you start to compromise the design of the building in the service of the construction system, like you've lost from a design to value point of view. We're trying to make sure we get clients the very best thing. So that's why we've started using more and more kind of kit of parts solutions. These are the sorts of metrics that we've been able to achieve, just to give you a sense of the scale of the benefits. Obviously safety, the industry is much better than it was, but that remains a big priority for us. So you can see here, by using fewer people and then having those people work in a much more controlled environment, we can dramatically reduce the potential for harm to people. And obviously that's massively powerful moving forward as we start to think about skills gap and aging demographic, and how do we start to diversify construction, making construction more attractive. Safety has got to be a key thing for us. We talked last week about why schedule's important to clients, and we're typically building things that are quicker but also cheaper and also safer. But speed has, as we talked about last week, lots of different impacts on clients. Sometimes that's just speed of generating revenue. Sometimes that's delaying the capital decision and allowing more time to let the design develop. The top left of this actually was, I think John talked about this last week. This was a pharmaceutical project where it's for a life-enhancing or life-extending drug. So like every month that we were quicker on this project, people didn't die, which is an enormously, on our value spectrum, that's enormously, on the right-hand side, that's a sort of big societal benefit. So sometimes we're looking at, speed helping clients generate revenue. In that instance, we were looking at speed saving people's lives, which is the sort of, problem statement that we like to tackle. Obviously, cost is important, and you can see here we're getting, not 2, 3, 5% cost savings. Potentially, we're getting sort of 20, 30, 40% cost reductions, whilst also being quicker. So we talked last time about how the sort of time, cost, quality triangle in construction is sort of fairly rigid. We often think that if you focused on, say, productivity, not only would you be working quicker, but you'd probably be working safer, you'd probably be saving money. So in our world, these things come together. You can get time and cost and quality benefits simultaneously. And this is a really important one for us. So particularly given, as I say, skills gap and demographic, we've had a real interest in, can we turn construction into tasks that are simple enough that non-construction operatives could do them? So I'm sure in automotive, it's not mechanics and engineers that make cars anymore. It's people who have been trained to assemble components in a particular way. So as far back as 2004, the airport project on the left, we actually set up a factory for one of our airport clients outside the wire, took a load of people from the local job centre and trained them how to assemble components. They actually made a really high quality piece of airport infrastructure. In the middle there, we've built pharmaceutical plants using ex-army people, and I'll talk a bit about the right-hand side. We've actually trained prisoners how to make components. So this is really interesting, particularly to, or this has become interesting to UK government, because this idea that if you could turn construction into more simple operations, suddenly you can massively diversify the labour pool, and suddenly you start to see solutions to skills gap and demographic, and how you start to change the nature of the construction workforce for the better. So one thing I showed those examples a few slides ago. Typically for a long time we were developing specific solutions for particular clients. So we were developing a particular solution for airports or for pharmaceuticals or for data centers. Firstly, that was going too slowly for us. So we haven't got time to change the industry, but one client at a time. And we started looking at, if you look at the numbers that manufacturing works at, no single client or even program of works has got the kind of persistent pipeline and the numbers that are big enough to really shift the needle. So we started a number of years ago, firstly noticing there was quite a lot of commonality between some of the systems we were developing, and starting to say, well, if you didn't think in terms of projects or clients or programs or even sectors, you started thinking about platforms that you could use across sectors. That might be an answer to how you start to shift these numbers. So I'm sure everyone's actually already familiar with the platform. The example I use is IKEA, because sort of everyone's probably got some experience with IKEA. So this, when you go to IKEA, it doesn't matter whether you're making a bed or a wardrobe or a chest of drawers or a kitchen cabinet. So whichever piece of furniture and whichever room it's in, that the components are always the same. That the book is always the same. You only ever need a hex key, maybe a screwdriver and a hammer. So IKEA, they weren't the first, but they're the most successful at taking all furniture and boiling it down to very small number of components, small number of processes, and a small number of tools. And you sort of know intuitively now that they've taken what was a very trade-based, skill-based, labor-intensive industry like construction, furniture making was, and they've turned it into a thing where suddenly everyone can make furniture now. So we started thinking, what was the version of that for construction? And I also like IKEA. When you go to IKEA, you don't buy a wardrobe and strap it to the roof of your car. You buy a kit of parts because it's logistically efficient. When you get it home, you don't build it in the drive. You take the kit of parts to, say, your bedroom and build the wardrobe where it's going to be used. So all of those ideas around kit of parts, logistically efficient, deployed at point of use, like what is that for construction, we started thinking about. So I touched on this project briefly last week. This actually started with the Ministry of Justice. So we were brought in, the problem statement we were given was to develop a new type of prison that would foster rehabilitation. We very soon realized you can't really design a building that sort of heals people. What you can do is design an environment that facilitates the right sorts of interactions, precludes the wrong sorts of interactions. The sort of value drivers that we were really balancing was the need for a sort of normalizing environment for prisoners versus the need for security and control. So bringing all those bits together, one output of that was a new type of prison that I talked about last week. We got rid of bars, we changed the cohort size, we got rid of the sort of galleries. So we got rid of a lot of the archetypal things in prison and developed a new sort of building block. But the other thing that we noticed was that, again, that we were starting to develop solutions that were common across a range of assets. So across the Ministry of Justice estate, they have health and education and offices and libraries and visit halls and gymnasia and canteens. So they've got the house blocks that are, their biggest building type, but they have all these other use cases that we started saying, well, if we had an idea that was any good for education for the Ministry of Justice, that's just good for education, we should start to propagate that more widely. So it started a conversation around how to more formally identify commonality and how you might start to get these common solutions. One of the other things we were interested in was this idea, as I said, of how to turn construction into simple processes. So for one of the building types, we designed a type of facades, literally designed it to be made using very low cost materials and very simple processes. And we said to MOJ, imagine if you could actually train prisoners to build the components. The reason you do that is because if you can teach them, manufacturing and warehousing and logistics, and you could teach them these skills, they'd be less likely to reoffend, more likely to find work. And you could actually use the building of the prisons to kickstart the thing the prisons are there to do, which is rehabilitation. So you could, even before the first prisons open, you could be helping rehabilitate prisoners through training and skills, which everyone really liked as an idea, to the extent MOJ actually gave us a prison. So these photos are taken inside a live prison. We set up a small manufacturing facility. We trained a team of prisoners how to make the components, how to put them together. On the bottom right, you can see a fully fitted out, fully working, high-performing piece of social infrastructure. And on the left-hand side, you can see about 75% of the tasks and skills needed were carried out by prisoners. So this started to get everyone really interested in this idea that actually maybe you really could start to componentize buildings and you really could start to change the demographics. And the feedback we got from the prisoners was off the chart. They were really engaged. They were thinking about better ways to do things overnight. They were coming in the mornings with ideas around how to, change some of the manufacturing processes. It was a real sort of, validation of this idea that you could suddenly start to really engage people in a different way of building. So that started UK government particularly using this sort of language. So this is this is language that the group called the Infrastructure Projects Authority. So in the UK, they sit between Cabinet Office and Treasury. So they own the sort of budget for our big pipeline investment. They set the policy and strategy. And so they're the kind of central group that controls the way that certainly social infrastructure is delivered in the UK. So this is their terminology. So in their terms, like IKEA, a platform is looks for commonality between asset types, enhances that commonality and uses that to derive a kind of common kit of parts that you could then be used at scale, and that's how you start to shift the needle. So that was a real change in thinking. I suppose traditionally people have looked at why sectors are different and special. So people look at why healthcare's so complex, why residential so emotive. So people tend to focus on the differences between sectors. But this was an opportunity to say, if you looked for commonality between sectors, I bet you'd find loads. I bet that would start to reveal something you could do at scale, and that's how you become much more like manufacturing. Why would you do that? Well, for all the reasons that manufacturing does, because if you had fewer components, you could optimize them better. So the example I often use is if you're going to use a bracket 1 million times, every gram you take out of that bracket, every handling process you remove has 1 million times a multiplier. And it's one of the things that manufacturing does really well is make these tiny incremental improvements, but magnify them by the scale of numbers of times it repeats things. So we started saying if you had a smaller number of components, you could really do that kind of manufacturing optimization. You could then start to boil down construction into IKEA-like assembly steps. You could diversify the workforce. So you get enormous benefits if you could get this principle to work, but you'd have to do it across sectors and you'd have to try and do it at scale. So this was one of our early diagrams that we used to describe this principle. So we said, rather than every project being developed, bespoke and new each time, every team being formed anew, there being no repository for learning to get sort of carried from project to project. We said if you had this kind of kit of parts on the right hand side of this diagram, you could have a digital library of all the components. You could then configure those components digitally to make specific projects, and that's how you step into the space that Maria and team are in, where you start to automate that process. On the left hand side, you could then have physical versions of those. You could have them manufactured at scale. You could have them assembled by potentially non-construction people. You could start to apply automation to that process, and this is how you start to dramatically increase the speed of design and the productivity of delivery, and make sure you're still getting bespoke assets, but also leveraging all the benefits of standardization. So this was our sort of vision for what a design deployment process might start to look like. So we actually put a book out on this in 2017. So off the back of the work we did with the Ministry of Justice, we actually wrote a book that said, here's what we've learned so far, here's what our thinking is, here's why you could develop a platform solution. And we deliberately called it Delivery Platforms to Government Assets, because we're saying certainly the UK, the only client with a big enough pipeline, long enough interest in the assets and ability to do this is the government. So if it had government backing, you could really get this to work, but it probably has to be government. So we started talking to government quite a lot at that point, sort of pitching this vision. And I won't go through all these documents, but it's become a very sticky idea. So as we get onto the right-hand side of this slide, you can see some of our key policies and strategies now have embedded this idea of platforms. The IPA started publishing increasing levels of detail around this idea of how platforms would change social infrastructure. So it's moved from a sort of thing we proved with one department, the Ministry of Justice, into something that's becoming much more prevalent across government thinking now. So one of the very early diagrams we used to explain this principle was this one. We said, look, if you plot everything government buys, it all sits on this graph somewhere. So if you focus on spaces, because when you buy schools, you're really buying education spaces. When you buy healthcare, you're really buying inpatient bedrooms and operating theatres to make patients better. So we said, if you think about spaces, everything government buys lives on this graph. You could imagine a sort of kit of parts that does you big empty spaces, gymnasia, warehouses and things on the top right of that graph. You could imagine a sort of kit of parts that does you things like the Ministry of Justice house blocks, would also do single living accommodation for the army. It would do student accommodation, so a sort of cellular repeatable accommodation kit of parts. Probably everything else lives in the middle. So you can imagine sort of mid-span kit of parts would probably do vast amounts of government spend. If you had that kit of parts, you could really start to change the dynamics. So cut forward a few years, we were then actually allowed to do the exercise for real. So there's a document here that you can download for free. We were given £50 billion worth of forward pipeline for these departments, put them all into a common data structure, which was a real challenge because no one had ever tried to do that before. And every department, every healthcare trust even has its own nomenclature, but we put it into Uniclass, so we had everything in a common data structure. Again, sort of data being the central pot that we put things in, and we could then start to do analysis across all of the different assets. So if you download the report, you can see loads of different visualizations we did, looking for the degrees to which the technical performance and the technical requirements were similar, and we found much more similarity, I think, than anyone expected. So some of the things that popped out of this Top left, we sort of knew this intuitively, but we could now prove it. Of the £50 billion we looked at, about 70% could all be built with the same superstructure system. So if you had this kit of parts, you could be doing it at enormous scale. And you can imagine how productive and how good you'd start to get at delivering this. Top right, this slide, it also showed why it hasn't happened before. So we found 104 different names for toilets across the government estate. So there's potential massive standardization, but it's hidden by the fact that everyone uses their own naming convention, for instance. So again, having the data allowed us to create these insights and really understand to what extent this might be achievable. So cut forward a couple of years, this has now become very, very prevalent in government thinking. The IPA put out a document end of 21 saying we plan to mandate this as an approach. So these are the sorts of benefits they're seeing. So, massive productivity gains you can imagine by deploying kits of parts at scale, disaggregated supply chains, so allowing anyone to make these components. So leveraging the existing supply chains to make these bits at scale. Suddenly you start to get a very distributed, resilient supply chain. Factory conditions on site we're going to talk about, but this idea of actually not necessarily moving things into off-site facilities, but changing sites into something more like a manufacturing facility would be even more powerful. And yeah, configuration tools you can see in, from Maria's talk, why that's important now. So for the last couple of minutes, I'll take you through an example of a project which is actually using these kits of parts. So this is an office building that we're doing for a company called Landsec. So they're the UK's biggest private developer. So there's already, I think, something interesting about an idea that we first proved and tested with public sector. Private sectors very quickly picked up and said, yeah, I can see the benefit. I'd like to deploy that myself. So this project, if you know London, it sits between St Paul's, and St Paul's is just across the river from it. The Tate is on one side, the Shard is on the other. So very prominent site, some very important stakeholders. So architecturally, we've had to design something very, very site specific. So given all of the constraints in that part of London, we've had to design a super site specific response. And you can see architecturally it doesn't look like it's a sort of very boxy building because it's a kit of parts, but it massively leverages a kit of parts. So we've broadly thought in terms of structure, facade, fit out, MEP. Structure sits in the middle of this diagram, not because it's the biggest bit of anyone's cost plan, but if you can nail the superstructure, it's an enabler of all the other things. So you can already buy unitized cladding systems that are millimeter perfect. Lots of people prefabricate mechanical electrical systems. What we were seeing is that a lot of the benefit of the manufactured bits gets diluted when it hits the traditional construction bit. So we found that in a facade supplier, 40% of their time can be measuring and bracketing and filleting and filling in the gaps between their millimeter perfect piece of facade and a superstructure that can be kind of plus or minus 50 mil and still be within tolerance. So we said if we designed a superstructure that was very quick, very accurate, had all the interface points pre-existing, then all the other bits are very easily installed as a kit of parts. So that diagram I showed earlier, where it had the sort of the graph showing the kind of spread of platform types, we've now got a number of these. And we use the numbers simply to denote the kind of spanning characteristics. Platform 2 is our mid-span platform. That's the one that 70% of the government assets could use. Platform 3, we've added one component to that to get bigger spans, so 9 by 9 meter grids for commercial office. But actually the platforms tend to use, again, like IKEA, lots of the same things. So whether it's a methodology in terms of automated design, a physical component, a process like use of color coding to identify components, we tend to mix and match these things. But it means that once we found or learned something in, say, commercial office, we can instantly deploy it in healthcare or education. So because we're using the same kit of parts across these multiple sectors, it means they're all moving quite quickly, and learning from one area instantly gets deployed in the others. So say we literally took, on the left-hand side is a Platform 2 superstructure for the Ministry of Justice. We literally picked that up with all of the color coding, the methodology, the means of installation, added a component, and suddenly it's good for commercial office. So all of the learning that MOJ has invested in instantly gets available to the private sector and gets handed back. Because we had a kit of parts, this was one of the projects where we didn't model the building, we auto-generated the model. So you plug in some key parameters, it creates a data set that describes the position orientation of all the components. From that data set, we generate the BIM model, but we can also do the procurement, we can do the fabrication and things. So every time there was a change on this project, we didn't update the model, we just generated a new one because it was quicker to do that, it took seconds. So we get very high quality information. We remove the potential for humans to break the rules, etc. And so we're leveraging that kind of stuff that Maria's team does to get and manage a much better data set. For some of the components, then we don't need to draw the components. The file goes straight from us to a supplier. So we're now getting into the space where we can take an auto-generated model. The file for the particular component goes straight to a robot. Again, much quicker, much more productive, and much more accurate. So the thing that arrives on site will be exactly what we modeled, because the robot doesn't interpret things and get things wrong. And then this was our prototype. We were looking at what level of automation was appropriate on site. So this was looking at, could we build the entirety of a superstructure without ever working at height? So you can see here, very simple tasks, color-coded components. We're measuring things in minutes, and a very small team of people can build a superstructure without ever needing to stand on the superstructure. So everything's lifted from below, the concrete's pumped from below, the little robot can level it. All of the fixing points for the MEP are already installed, and it's super accurate. So on 9 by 9 meter bays, we were plus or minus 5 millimeters, which means that everything else fits as a kit of parts. So one benefit of that was it was much, much more carbon efficient. So we took about 30% of the embodied carbon out of this project. Obviously, virtually zero waste on site, better control of vehicle movement. So all of these things contributed to this being UK's first net zero commercial building. We also had a team from University of Cambridge crawling all over this building to get a load of metrics, which normally aren't worth gathering because every building's bespoke. But when you're developing a kit of parts, anything you can learn from this project has massive power, because you can then feed it back into the next generation of components. So we had a team of PhDs observing everything on site, looking at the site records, looking at the as-built records and things, and they found some really interesting things. So one thing they found was that variability is massively important in these projects. So it shows that it was possible to put 12 bits of steel up in a day, but on lots of days they didn't do any. What it showed was that if you'd just been consistent, not been quicker, but just been consistent, you would have been 25% faster, which is really important to know. It showed that there were all these downtimes that where activities weren't happening. So this is teaching us how to plan the next phase of these projects, where we won't have Gantt charts, for instance. We'll look in terms of piece count and say, just put up 6 bits of steel every day. This was really important. It showed that the system was about twice as productive as precast, for instance. So precast is very quick. But even on the first project, even with the learning curve, we were very, very productive. So we were nearly twice as productive maybe as traditional construction, which again, given the McKinsey graphs you've all seen with flatline productivity, that's massively powerful. Without also introducing all the kind of time and cost with precast. So we were getting precast quality finish on the left-hand side, but without the downtime and the lifting and the moving and all the additional steps that precast takes. So we're currently about twice as productive as precast, slower but much more productive. But you can see here, without all the non-value adding and carbon introducing steps. So again, it tells us we're onto something quite powerful with this. The University of Cambridge team also did these studies where they said if you didn't go any faster, but you resequence things to take out all those non-productive periods. So don't go faster, but if you organize things to be much more consistent, you could potentially take 40% off the program. So we've already got a system which is demonstrating you can be twice as productive and probably build things in half the time. So this would address the kind of time difference between this and precast. So that is gold dust, because we now know that we've got a system we could deploy at scale, which dramatically increases productivity, massively increases quality, and potentially could be built much, much, much quicker. The facade wasn't unusual. It was a fairly normal facade, but because of all the pre-work we'd done, it went up lightning fast. So they'd planned to do 7 facade panels in a day, so 1 an hour. At peak, they were putting them in every 7.5 minutes. So theoretically, you could have clad this building in a week, not because of anything that we did unusual in the facade, but all because the superstructure was designed to be ready for the facade to be quickly installed. And the same thing on the MEP, because we'd pre-designed all the fixing points. NG Bailey, who were the contractor, set up their factory with bays, benchtop things set up, dropped the MEP in, wheeled that off the floor into a truck onto the floor plate, and on the right hand side then used a specially adapted forklift to pick up all of those cassettes in one hit, staple them to the ceiling, move on, staple them to the ceiling. So a single operative could do massive amounts of MEP in a single day. Looks amazing. And again, you can see that the numbers, left hand side is industry best practice, right hand side, once they got the hang of using that little bit of automation, the install time has absolutely plummeted. So again, we're demonstrating that you could be much, much quicker, much more productive using these sorts of techniques. So this was my last slide. You can see here again, without going any quicker than we're already going, you could potentially have built that building 40% quicker. So if you imagine taking that learning, moving it forward, multiplying it by the scale potentially of UK public sector. As I say, not the finished article yet, but we're definitely onto something. And hopefully this shows that there's some techniques here which are really demonstrating how we could dramatically change time, cost, quality, carbon at scale across construction. Apologies, that went on longer than I expected to. Sorry, Margie, but
we
it was worth
wrapped.
going through some of that.
The whole audience was completely wrapped, so no problem about that. First, I just want to say, wow! Every time I talk with you, I'm so astonished at what the thinking behind this and what you have been able to achieve. And I guess my question to you is, as you think about coming to the United States with this idea and this experience, where do you see the opportunities most likely here?
Well, so there's nothing in what I've shown which is UK specific. So there's nothing that we've shown which is anything to do with the UK industry. I think we're trying to solve problems which are prevalent across the whole industry. The interest we're getting is particularly from sort of big serial owners, you can imagine, who have a rollout of things, who want to move quickly and get to market quickly. So data centers particularly, we see healthcare probably as something that, you know, we've got lots of experience in that space. We think that that sort of sector somewhere where we can add value. I think residential, we've talked about last week, we failed to crack in the UK. But the reason I wanted to show, say, the Prism thing was to say, look, we've got some thoughts around resi. That seems to be a topic globally that we could address. So I think it's going to be a mix of those sorts of high value, fast moving sectors, so data's health, other social infrastructure, say housing, and I don't know, you know, virtually everything in between is probably up for grabs. But yeah, as I say, nothing that I've shown is UK centric. The idea is that all of it could be propagated, you know, very widely, and is all, you know, totally applicable for the problems in the US or the challenges in the US.
Well, the housing crisis is profound here, and I know it is profound as well in the UK. So we'll be looking forward to some solutions there, as well as in many other parts of our industry. Maria and Jaimie, I want to thank you so much for your time today. This has been just a wonderful morning, and unfortunately, we're going to have to end now. We just cannot thank you enough. We're so excited to hear what you're going to be doing here across the pond, and we wish you all the best. We'll be hearing from you, I hope, in the coming months. Brilliant. So thank you for joining us.
Thanks so much, everyone. Thanks.
Thank you.
Yeah. So this concludes today's Center for Innovation event. Please join us later this month for a conversation with Doug Moore from McKinstry. He's going to explore a very different topic. What happens when a building developer unlocks innovation by adding funding for research and development to a project? Doug's going to describe the South Landing development in Spokane, Washington, a zero carbon, zero energy project that launched new innovative market offerings, and how this transformative project employed new innovative thinking to the development process. You won't want to miss this. As a last note to our audience, the recording of this session will be placed on YouTube, and we invite you to share it with your colleagues. Thanks again to Jaimie and Maria for just a fantastic presentation. And thank you to our sponsors who make all of this possible, and for all that you are doing to transform our industry to create a better world for everyone. For the Americans in the audience, please be sure to vote in next week's elections, and we'll see you soon. Thanks for joining us.